Well, welcome back, folks. Today we're going to get on with some long talked about maintenance activities here for the little 4.8N. Previous video I removed the hood and we had a little brief conversation about the apparatus I put together to remove the hood so that I can easily do it alone. Now we're going to move on to the maintenance items. We're going to retorque the head bolts and the two head nuts. I'll come back and talk about that in a moment. We're going to do a compression test, follow-up compression test. Some of you have been with me for a while may recall, I think it was last October, that had been October of 24. Right after I got this tractor, I did a compression test. Initially, just to get a baseline, and I did the valve job last winter. That is the whole valve train I went through and ground the valve seats, etc. Now I'm going to do a follow-up compression test to see where we're at. I don't think it's still great, to be honest with you, because she still is puffing a little smoke, but I think that's due to rings, not valves. But nonetheless, I'm going to do a compression test, a follow-up. I will have to warm up the engine for that. To properly do a compression test, you should have the engine to operating temperature and the throttle wide open. You can do it with the engine cold, but it's not as accurate, so we're going to do a compression test and then get into the generator here and do some testing, probably repolarize it and get an idea of where we're at with that generator in case I have to take that off and have it rebuilt. Another thing I'm thinking about doing is repainting this air intake tube right here. You can see it's a combination of red and blue. That's always kind of bugged me. And if I'm going to paint the tube, I might as well paint the air cleaner housing here. So the repainting of those two items is not a sure thing, but it's a probable. But first we're going to do the other items, the mechanical items we just talked about. So let's talk about the torquing of the head bolts. As with most equipment, there is a recommended torque sequence for head bolts on this engine. And you can see here actually the diagram. And you can see they're numbered, so you have what number? 1, 2, 3, 4, where's 4? 4, etc. So you just follow that sequence. Generally you start from the inside and work out like this. And then here you can see the recommended head bolt torque. Remember now, on this engine I have both bolts, which originally came with it. Then I have two nuts that hold this conduit on here and here. I replaced those two bolts that support that conduit with studs at the suggestion of one of my viewers. He says it's a lot easier if you have to pull that conduit off, put studs in with, and then double nut it so that you can easily remove the conduit and do whatever you need to do, such as we're going to do here today, and that is check the head bolt torque. And that way you don't have to disturb the torque of the head studs themselves or bolts. So that's what I did then, and we're going to end up removing those two top nuts so that I can move that conduit out of the way as I get at some of these bolts back in here that are really hard to access with that conduit in place. So that's really what we're going to start with, is removing those two nuts and so that I can move the conduit. I am going to do the head bolt torque with the engine cold, which is typically the way it is done. And we're going to start again with removing those two nuts. I removed the spark plug leads because I'm intending to move this conduit up and back and forth. So I want to create plenty of play. I think there's going to be enough in the wires. These nuts, you may recall I had applied just a little bit of Loctite to the threaded portion of the stud when I put them on last winter, just to prevent them from vibrating off. But I am expecting that they'll come off, the nuts will come off pretty easily. These are 11/16 nuts, by the way. Now the paint on these nuts and the bolt heads, for that matter, that would be these bolt heads. And when I torque them, it's probably going to get chipped. That's okay. I will touch them up. The reason I'm using a wrench and not a socket is the clearance here is pretty tight. And though with a universal, I could probably make it work. I'm not in a rush, so I'm just going to take my time. There's one. I'm trying to be delicate around that paint and damage as little of it as I possibly can. I can feel the Loctite. That's blue Loctite, by the way. It's not permanent. Obviously, I wouldn't use permanent in something like this because then I would have to heat it and get it pretty hot in order to break the Loctite seal. And you can see the remnants of the Loctite. Now it should be just a matter of lifting this conduit off carefully, like that, so I can move it back and forth. That's the whole idea, so I can move it back and forth like this when I'm torquing these head bolts. So let me get it set up for the torque wrench, and we'll go ahead and torque these down. I think I got everything ready to go. You will notice I put some blue tape, painter's tape around these areas on the conduit where the torque wrench extension is going to come close to the tube, the conduit. Just a little precaution. It takes just a second. Tape's cheap. I'm doing my best to avoid touching this. That's the whole idea of creating this movement and this freedom of movement here, but just in case. Again, I'm going to be following this torque sequence, 1, 2, 3, 4, let's see, 5, etc. I will have to switch from 65 foot-pounds to 50 when I get to these studs right here. My theory on torquing is I go to the lowest number. This is old hardware. The bolts are old with the exception of the 2 studs which were new. But this is 75-year-old hardware, and I'm not going to stress it any more than I absolutely have to. And so my theory is go right to the minimum. That'd be 50 for the nuts. That would be these 2. And 65 foot-pounds for the bolts, which would be everything else. So that's what I'm going to do. So midstream here, I'm going to have to change the torque. Now, I'm not going to do a lot of narrative here. I'm just going to get to it. And if there's anything relevant that I think that we need to talk about, we will. But I'm just going to start torquing these head bolts. I'm going to be laying this document right here so that I can use it as reference and keep track of where I'm at as we go. So I'm going to start here with number 1, which is right here. And you can see why I put tape here, because even with that being loose, it might want to rub. 65 foot-pounds. Number 4 is one of the studs, and that's 50 foot-pounds. And so is number 5. They were okay, actually. Now we're going to go back up to 65 foot-pounds. Okay, we completed the complete run of all the fasteners. Most of the bolts did require tightening. The wrench moved a bit on I think all the bolts pretty much. The 2 studs seem to be tight. They torqued right out quickly, so I think these are okay. The rest of them did require tightening up. What I'm going to do now is I'll just go through one last time and check each one of them, make sure, and then I'll put the conduit back in place. Get the wires back connected, the spark plug wires, start the engine and warm it up so we can move on to the compression test. I'm not going to show all that because that's kind of repetition of what you just saw. One last comment I wanted to make on replacing these 2 original bolts with these studs and then double nutting it to hold the conduit on. As I mentioned a few moments ago, that idea was provided to me by one of my viewers, Keith. And Keith, that was a great idea, and I appreciate you sharing that with me because it made this so much easier and to get access to all these fasteners without taking the risk of damaging this tube and bending it back and forth. So it's a great idea, and I appreciate you sharing that with me. About 2 minutes later, got everything back in place, conduit's back in place, a little Loctite on the threads of the studs, and just snug those top nuts down just enough so they don't vibrate loose. And got blue tape off. I think we're ready to go to the next phase here, and that is checking the compression. So what I need to do now is start the engine, let it come up, let it idle for a few minutes, come up to full temperature, shut it down, pull the plugs, and then we'll do the compression test. About 10 minutes or so later, the engine is good and warm. I think it's at its full operating temperature right now. The upper radiator hose is hot, which tells me the thermostat has opened. I wanted to mention one other thing regarding the rings, the piston rings. The reason I think they might be a little weak is I do see a little blow-by coming out of the filler tube on the opposite side of the engine. You can't really see that from this perspective, but I do see a little puffing out of that as well, which means it's got a little blow-by in the crankcase. So I wouldn't be surprised if we're still not weak on compression. By way of reminder, here are the original readings I took, 8, 9, 10 months ago. Number 1 was 80 psi, 2 is 80, 3 is 85, and 4 was 110. So we don't want to be any lower than that for sure, and we'd like to see it come a little bit north of that. 80 is generally, I think, on these engines considered about the minimum you want for compression. So what we're going to do is start with number 1. It'd be at the front of the engine, pull the plug, open the throttle, make sure it doesn't start, of course, and crank it a few times and see what happens. I have all 4 spark plugs loosened. I'm going to leave these 3 in for now. I'm going to go ahead and pull number 1 out. Again, I'm curious. I think it's pumping a little oil. And yeah, no gasoline. But she is pumping a little oil on number 1 for sure. And that was one of them that was light on compression. That was 80 psi. We'll set up the compression gauge and we'll see what happens. She's at, I don't know if you can see that or not, about 70 pounds. It's actually down from what it was the first time around. Let's move on to number 2. Number 2 spark plug is also a little oil fouled. See there? Number 2. That's about a little over 70, 75-ish. Number 3 is a little black also from oil. Yeah, and that's about 85. Number 4. Yeah, it's about 100, I would say. Well, there's no question in my mind that the rings are weak. All 4 of the plugs showed, I think they're just cool enough to touch now, oil fouling. I'll clean those all up before I put them back in. Also might be a little bit of carburetor adjustment left that I need to work with, but it looks like oil fouling to me. And couple that with a little wisping out of the exhaust as well as out of the breather, the filler tube, I'm pretty sure we got some weak rings. I went back through and did a second round just to verify my numbers on all the cylinders off camera. Pretty much came out the same with the exception number 3 came up just a bit. Number 1, 75, this is the current round, this is the previous from 8 or 9 months ago. Number 1, 75, number 2 is 80, the PSI of course, number 3 is 90, and number 4 is 110. So, bottom line is the valve job didn't really do anything for compression, but I'm glad I did it anyway because it needed to be done. But clearly the rings I think are a little weak. We had polished cylinder walls as well, no cross hatching left, so who knows when the last time this engine was majored. And I know it was majored at least one time. We'll probably talk about that in a separate video, but this engine has been majored before, but it's probably been 55, 60 years. Who knows? Anyway, it's a little weak on compression still, but it does run okay, so I'm not going to worry about it right now. I'm going to clean up the plugs, put them all back in, and move on to the generator. This generator, though, is an original type generator and probably was from the era. I don't know if it was original to this tractor. Probably, but I don't know for sure. This is a internally grounded type B generator, at least based on all of my research that I've done. There were a number of generators, of course, used over the years by Ford, and they changed the configuration, and the way you test them and polarize them varies depending on which type of generator you have. That's why I needed to determine what type of generator this is. And again, this is an internally grounded type B, I believe. In fact, I'm very confident of it. You can see where I took a sharp-tipped Sharpie and highlighted the stampings, G and D for ground, FLD for field. Those stampings were hard to read, covered with paint, a little corrosion, so I just outlined them so they were, the nomenclature was very easy to see on camera and for my own purposes. This is the wire that comes from the armature, or goes to the armature rather. All of these wires connect over at the voltage regulator, which we're going to talk about next. The voltage regulator, which you have seen before, we talked about this a little bit last winter when I had this all apart. Cleaned it, painted the cover, which I will probably paint again when I paint the air tube coming from the air cleaner canister and the canister itself. I might as well paint this again. You can see it's got a few little chips in it already. What we're going to do now is polarize this generator. And the way we do that is, in fact, you can see all the wires I've got disconnected just for safety reasons. The ignition system is turned off. I got the key out. But it's a real simple process on an internally grounded type B generator. We're going to connect or touch the battery wire right here, this is the solid yellow, to the black and white wire right here, which goes to the field terminal on a generator. And what we're going to do is just touch those together momentarily. You might see a little bit of a spark, and that's perfectly fine. It's just like for a second or so. That's it. Now the generator should be polarized properly. I'll put the wires back in place, and then we're going to do a little test on the generator, a basic test to see if in fact the generator may be working. This next test is going to suggest whether this generator is good. It's not definitive, but it will tell us for sure if this generator can act like a motor, which it should do if connected properly. So what I've done is I've run a lead here from the field terminal up and around to a good ground on the machine. The opposite end of this black jumper right here is connected to the negative terminal of the battery up here. I'm going to connect this end to the armature here, and that should spin this generator and make it act like a motor. Now I have disconnected the fan belt here for obvious reasons. I'm not trying to turn over the fan or the engine. I just want to see if this spins. So let's see what happens. And it does spin, so that tells us that this is probably good. I think there's more testing we're going to have to do to determine definitively whether in fact it's putting out current like it's supposed to. We validated the generator at least spins on its own. The brushes are functional and it can act as a motor. We have not validated at this point whether the generator actually provides current or an output. I've got to give some thought to what my next steps are, whether I continue with the generator or I move on to the regulator and do some testing there. I haven't decided yet. I got to do a little research and some thinking on that. So I think at this point I'm going to call this video to a close. In the next video or two we'll get into what the next steps are with the electrical system. So that's going to be it for today, folks. Any issues, questions, thoughts, drop me a note. Otherwise, as usual, thanks for watching.